Hello, judges. Today we're going to be presenting about Artemis Prime. So you're probably wondering, what is the product? It's a search and rescue vehicle and autonomous drone that supports individuals during hazards.
So how does Artemis system function in response to a real-world hazard? First, we want to connect to Starlink satellite. Then Artemis's vehicle will emulate Starlink satellite's Wi-Fi to survivors. So how the drone plays in action is by autonomously following Artemis's vehicle for a bird's eye view.
Now, what problem does this product fix? Most recently, there were earthquakes in Turkey and Syria that caused massive infrastructure damage and caused many lives being lost. Now, the emergency situations created by the earthquake make locating survivors and hazards difficult, as well as communication networks being disrupted. Some ways that we're trying to fix this is by having a camera with object detection to better locate survivors, and to have Wi-Fi that can help communicate with services and loved ones amidst the infrastructure.
So who is buying Artemis? Right now, we have government agencies, UNICEF, and military contracts.
What are the tasks of Artemis? Well, Artemis needs to be an autonomous rover that emits Wi-Fi and needs to have an auxiliary autonomous drone that follows it and detects survivors. And it also needs a mapping application to pinpoint the location of the survivors. And we can do so using a Raspberry Pi and a Wi-Fi access point and ML models to detect survivors.
So is it reasonable to implement this project in the real world? Yes. First, it's easy because it's an easy method to find survivors that have access to their phones and can connect to Artemis's internet source. Second, it's useful in hazardous situations like the Turkey earthquake, like mentioned before. Third, it offers quick response to pre-scout minimize lives lost in the aftermath.
So how to make the rover a Wi-Fi access point? Well, the Raspberry Pi comes with a Wi-Fi adapter, which allows us to set up a network and a DHCP server and enable the server to reboot and reboot the Raspberry Pi to emit Wi-Fi.
So the first thing that we did was drone autonomous face detection. So the pros of it is fast, efficient data, real-time monitoring, high degree of accuracy, and it identifies humans and follows them. So what is needed for drone object detection? First, object detection enables drones to automatically identify and track objects of interest. Second, provides an enhanced bird's eye view in complex environments. And third, can be trained to locate survivors and hazards.
Next, this is live footage from the drone's POV doing object detection as it flies. As you can see, you can identify people and chairs, as well as different objects in the room.
This is the iOS application that we use. It creates a perimeter around the user's location. In the future, we're hoping to add the Wi-Fi access points of individuals around the surrounding area, but further development needs to occur.
So the next thing that we did was a driver user interface. I created a UI to depict how the app will look like. First, it's an easy to use application for drivers, so they aren't focused on more than one thing when they go to save lives.
The challenges we faced were a lot of hardware and time challenges. We've had a lack of components to assemble the Raspberry Pi and rover, and the power supply wasn't able to withstand the Raspberry Pi. And also the drone had a lack of bandwidth, which made object detection very difficult.
Some solutions were we bought batteries from Walmart, then we condensed the rover's functionality. Third was getting and creating a drone that fits the team's requirements better. And fourth was used object detection on the drone feed to deal with low bandwidth. So these are some next steps. The first thing was the rover hardware development. The second was app development, and third was launch of the first official prototype. Thank you.
Thank you.
Thank you.